This video will discuss the results from the Week 5 Mob Lab recitation activity. Before completing any of the Mob Lab activities, you are asked to sketch the two markets given below and comment on the price elasticity of supply relative to the price elasticity of demand in each market. In Market 1, the demand curve is P equals 200 minus 10 Q sub D, and the supply curve is P equals 5 Q sub S plus 80. In Market 2, the demand curve is P equals 200 minus 10 Q sub D, and the supply curve is P equals 0 plus 15 Q sub S. The first thing we want to do is sketch two graphs with axes Q on the horizontal axis and price on the vertical axis. In Market 1, the demand curve is P equals 200 minus 10 QD, so we know that the price intercept is 200 and there's a slope of negative 10. In Market 2, the demand curve is the same. In Market 1, the supply curve is P equals 5 Q sub S plus 80. So in Market 2, the price is equal to 15 times Q sub S, which means that the price intercept is 0 and the slope is positive 15, which is steeper than the demand curve. So the supply here is less price elastic than demand. So in Market 1, supply is more price elastic than demand, and in Market 2, demand is more price elastic than supply. When we solve for the equilibrium price and quantity in both markets, we get an equilibrium quantity of 8 and an equilibrium price of 120. In the Mob Lab activities that follow, you'll be playing the Market for Oranges game with markets that resemble both Market 1 and Market 2. First, you'll do this with no government intervention, then with a price ceiling, then with a tax. Here we have Market 1, and you can see that the equilibrium price in this market is equal to $1.20, and the equilibrium quantity is 9. In this particular market, when you all played, you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 oranges are bought and sold. And that as time progressed, that the price converged to the equilibrium price. On average, across all markets, when you played, the average quantity transacted was about 6.67 oranges, and the average price was about $1.28 per orange. In Market 2, we can see that once again, that equilibrium price is equal to $1.20, and the equilibrium quantity is 9, and we can see that in this market 1, 2, 3, 4, 5, 6, 7, 8 oranges were transacted. On average, across the entire class, the average quantity of oranges transacted was about 7.91, and the average price of an orange was about $1.12. So you can see that the prices, while they're not always at equilibrium and the average price isn't at equilibrium, over time, the markets tend to converge to the equilibrium price. So now we want to think about the effects of a price ceiling. And here we had a price ceiling of 90 cents. A price ceiling of 90 cents is going to prevent the price from rising above a certain level. above 90 cents, to be precise. And so what we would expect is that the quantity supplied would be less than the quantity demanded in both of these markets. And we know that the quantity bought and sold is going to equal to the lower of the quantity demanded and quantity supplied. So we would expect the quantity bought and sold to be the lowest in the market where supply is relatively more elastic, which is market 1. So now let's take a look at your results in each of these markets and see in which market did quantity decrease by a larger amount. So in market 1, with that price ceiling of 90, we would have expected 3 oranges to be bought and sold at a price of 90 cents. On average, about 1.52 oranges were sold in these markets, and the average price was just under 90 cents. And as you can see, in this sample market, there were 2 oranges bought and sold. Moving on to market 2, where supply is less elastic, we're going to expect to see a higher quantity of oranges bought and sold with the same price ceiling. So in market 2, again, we can see that the quantity of oranges bought and sold, we would expect to be 6. In this sample market, you can see that there were indeed 6 oranges bought and sold, all beneath that price ceiling of 90 cents. And on average, across all markets, about 5 oranges were bought and sold in each market, and the average price was about 66 cents an orange, so below that price ceiling of 90 cents, which is binding because it is below the equilibrium price of $1.20 per orange. The next thing we want to consider is a tax of 60 cents. So when a tax of 60 cents is imposed in these markets, then we're going to expect that the price that buyers pay will increase from the equilibrium of $1.20, and the price that sellers receive will decrease from that equilibrium price of $1.20. And this should also decrease that quantity bought and sold with the tax. Additionally, when we're thinking about how the surplus is split, because in market 1, the supply curve is relatively more elastic than the demand curve, the buyers are going to bear a larger burden of the tax. Whereas in market 2, where supply is relatively less elastic than demand, the sellers are going to bear a slightly higher portion of the tax. And we can we know this by looking at the price that sellers receive versus what they were receiving before versus what are buyers paying now versus what they're paying before. So if we look at the results, we can see that in market 1, when that tax is imposed, creates a wedge in between the price that buyers pay and the price that sellers receive, and decreases the quantity. So in this market with a 60-cent tax, the quantity we would expect would be about 5 oranges transacted. The price that buyers pay should be about $1.60, and the price sellers receive should be $1, with that 60-cent wedge now between the price that buyers pay and the price that sellers receive. And because the previous price, previous equilibrium price was $1.20, That means that of the 60-cent tax, buyers are paying about 40 cents of it, 160 minus 120, and sellers are paying about 20 cents of the tax. So you can see that buyers bear the larger burden of the tax. When we look at how you all behaved, we should have seen the transaction price at about $1.60. But what we ended up seeing was transaction prices much, much lower, actually closer to $1. And I saw this in both Market 1 and Market 2. We'll see that shortly. But there were a lot more oranges sold than we would expect, and the price was a lot lower than we would expect. My hunch here is that this is because you all didn't quite understand what the goal was as sellers. So the goal was to maximize your producer's surplus. And so I think you guys anticipated that the price that sellers receive should be lower, but the transaction price of the oranges is actually going to be higher because the sellers then have to pay that 60-cent tax to the government. And what we ended up with here was the majority of sellers actually ended up with negative surplus. So doing worse off than if they hadn't sold these oranges at all. So now in Market 2, when this tax of 60 cents is imposed, we would expect the price that buyers pay to be about $1.45, and the price that sellers receive to be about 85 cents, with the quantity equal to about 6. And what you can see is that we would anticipate then that compared to that equilibrium price of 120 from before, buyers are now paying about 25 cents more, 145 minus 120, while sellers are receiving about 35 cents less, 120 minus 85. And once again, we would have expected that transaction price to be higher at about 145 and only 6 oranges bought and sold. But when we look at the data from you all, the average price in the market was around $1. On average, about 10 oranges were bought and sold in these markets. And the average seller surplus was quite negative. So you all actually would have been better off not selling a lot of these oranges, or trying to charge a higher price and then ending up not selling more of these oranges. So you actually do worse off when you sell an orange for negative surplus than you would not selling that orange at all.